Hey everybody, welcome back to another edition of Gruber Wired. I'm Mark Beach.
I'm John Dotson, and today we have special guest with us, Ty from MacDermid Design. How are you doing,
welcome
Ty?
back.
Good. How's it going, guys?
Yeah, glad to have you.
Yeah, it's
Thank
been a
you.
little while. You were on with us, what, about 4 or 5 months ago?
Yeah, I think about that. Yeah,
Yeah, time flies, doesn't it?
Good stuff.
about due for another stop back
by
in.
popular demand.
All my fans were hollering for me.
Yeah, we were getting clobbered on social media. We had to relent.
There we go.
Oh,
That's okay. We bend. We just don't break. Right?
Right. One question: how's Shop Dog doing?
She's doing great. Yeah, it's still being a nuisance, still running around, doing her thing. Her new little weird thing that she's got going on. She likes standing on top of complete parts. So if I have like a box sitting there, she'll just stand on it, and I'm like, can you not?
If you get a box full of dog hair,
Yep,
right?
that's
There
my
you
bad.
go. She was just doing quality control.
That's what it is.
That's
yeah.
it. That's it. Yep. Hey, Highlander, welcome. I see you're here. Hey, if anybody listen, if you have any comments while we're live, feel free to share them. Any questions for Ty or us? Take advantage of it. Otherwise, if you put comments in and you're watching this on a restream, then we will try and get to your comments as we notice they appear.
Yeah.
There we go.
When they show up. But Ty, before you were on the show, before we went through a little bit of history of who you were, where you came from, what you do, talked about your business and your shop and your manufacturing. We just want to dive more into the manufacturing side of things today.
Sure. How do we take something that's a vision and bring it into reality?
Yeah,
Yes.
we do a lot of custom work here, and we get a lot of ask for a lot of custom designs, and that's where we would come to you, correct? And,
Yeah.
I'll say, hey, Ty, what do you think about this? And I'll send you some pictures, and you're really great with taking a picture and envisioning where that's got to go.
Yeah. So I deal with basically everything from like photos of, hey, can you make something that looks like this? Or, scribble down notes on the back of a napkin to, if you have a completed CAD model, that's cool too. So really any stage that you guys are at, we can kind of help pick it up and take it into something that can be produced.
Yeah.
Nice. Kind of puts the onus on the customer to have imagination, doesn't it?
A little
Yeah.
bit, yeah. I can help, but your specific application you probably know better than I do.
Yeah.
So you can definitely get a little creative and help come up with ideas.
Yeah, I've seen it done. I've had that napkin scenario before,
Yeah.
so I get it. Yeah.
Yeah, it's
Very
always
cool.
it's always fun. It's never the people that you would expect that comes with like the complete CAD project. Like you would think, oh, this guy's probably just gonna have some scribble down notes, and he's like, no, I have full engineering. It's all done. Here's the design. Let's run it.
Yeah.
But
Yeah.
either way, you start somewhere, right? So if
Yeah.
someone brings you a piece of paper and has a drawing on it and says, here you go.
Yeah.
What's your procedure for starting there to get to the next step?
Yeah, so the first thing that we're always going to do is get a model worked up in CAD or computer-aided design. So there's multiple different softwares out there that do that. I use SolidWorks. It's pretty industry standard for sheet metal fabrication. There are some other ones out there, but it has a lot of design functionality that works really well. So we'll take a part or a sample, notes, anything like that, and digitize it into a model that is something that we can spin around in virtual space, make sure all the measurements are right, generate a print and send it over to the customer to kind of see if it looks okay. And if the print looks good, cool, let's make a sample and go from there on the testing side of things.
Has 3D printing come into play in what you're doing? So are you able to make like scale 3D printed versions of something?
Yeah, I definitely can. There's not a ton of use case in the sheet metal world just because my final product is going to be like a thin piece of sheet metal. So
Right.
maybe not even 1/8 of an inch thick. So 3D printing something like that, it doesn't have a lot of structure that way. So it can be a little fragile.
Gotcha.
But for things like fitment testing or fixtures, jigs, things to help bend in custom radiuses, I've done custom tooling for that all on my 3D printer and doing that.
Nice.
And I don't have like a crazy 3D printer. I have just the cheap one off Amazon, and I use the off-the-shelf plastic, and it does actually really well in the manufacturing environment.
Yeah, my son uses the 3D printer to create stuff for his like video rig.
Yeah.
Because it's like, well, I can go and spend $200 or $160
Yeah.
for one that's pre-made, or I can just print it out which is pretty cool.
And I'm sure he starts with some level of design and he draws his thing up and puts it in his 3D printing software. And that's essentially what we do, but sometimes it's just out of metal.
Yeah, for sure.
Sure. So if I want to come to you with something like this, where's a starting point? What would you suggest?
So my preferred method is if you do have a CAD model already worked, just because selfishly that makes it a lot easier on my end.
Yeah.
But really, it doesn't matter. You can just come up to me with an idea of like, hey, this is a thing that I want to make. I have no idea about the execution or anything like that, and we can kind of help work backwards. Or if you, a lot of times, CAD in the beginning stood for cardboard aided design, and we could take a look at the first picture on our list right there to kind of show what that looks like. But I've had customers bring me things like this, where it's just corrugated cardboard cut up into shapes, and they taped it up together, and that gives them an opportunity to put it inside a vehicle or in the application or whatever to make sure it fits, and then we can work backwards and make it out of metal and get it done. So that's kind of
an analog version of CAD.
Yeah, exactly.
Cardboard aided design. Yeah.
If someone comes to you with a mock-up that gives you can visualize where they're going, you can take measurements off that.
Yeah, and then I pull all the data that I need off of it. Something like that gives me a lot more flexibility too, where, maybe it would be a little bit better if we made this all one piece or split this into two pieces or something like that. Whereas if you come to me with a print and you're like, no, it has to be this way, then I'm obviously working under your constraints, which isn't a problem, but something like this gives us just the opportunity to kind of change things and make it potentially easier to make and even more affordable on the end customer.
That's cool. Now, I have to ask, what is this used for?
So that is actually a fuel cell for a race jet ski. So Commander Industries, they do performance jet skis. They're the fastest in the world. I think they actually just set a new record. But they come to us with kind of oddball things every now and then that they take factory jet skis and build aftermarket components for them to make them go fast.
Oh, that's cool. So, just asking, do you work with NEMA rated in this area since this is going to be marine operated?
Not on that specifically because it's like the power sports world, but in the past we've done other electrical cabinet enclosures and stuff like that did have NEMA ratings that go with them. And there's a lot that goes into it, but essentially what it boils down to is like, is it waterproof? Like if it rains on this, is the stuff inside going to get wet? And that's totally doable. So, but yeah, for things like this, that's going to be used in a marine application, we'll just choose a different type of aluminum. So 6061 has better corrosion resistance, and corrosion is going to be your main issue in a marine environment. So we'll go with that. We'll use different methods of welding it and all that kind of stuff too to make sure that it's going to hold up over time.
Wow. Since we talked there for a moment about the marine environment, what about like seismic scenarios? Like doing projects for, say, California up along the...
Yeah. So that would be something that like a structural engineer would definitely have to worry about. And there are some instances where, we would have to look at that, but that's going to be more on the design simulation side, and that's not necessarily something that I do, but I have worked in that environment as well with our military customers. So they'll build units and they actually take it to essentially a shaker table, which is you bolt this thing down onto a table, how it would be mounted on a Humvee or something like that, and the table just violently shakes it for like 2 days straight to simulate it being on a dirt road for 10-15 years at a time. And then what they'll look at is, did it crack? Did a piece fly off? Did this happen? Did that happen? And then if so, then it gets rejected. You got to fix that part, make it stronger there, and then go that way.
So when you do have things like you do that and you end up having like a stress crack or fracture in it, is that repairable, or is it you need to start over again?
No, so that would all be done inside like the design and prototyping phase. So for military specifically, if it's okay if it breaks, but not basically they don't want pieces flying off is the deal. So if it breaks, it has to stay contained. If it does, obviously, if they find a crack or something that it didn't fly off, but it still broke, they're going to fix it. That way it's not that problem. But it's not so much of a repair as a let's walk backwards. Let's look at the design and how can we do that section differently where it may be stronger. Should we, make it out of a thicker gauge material, change the type of material, or any number of things that can kind of help make that non-issue moving forward.
Pretty cool.
Yeah, it's like the... it's the same but different. The ashtrays on the submarines, you know, because they're $500, right? But they're designed, if they break into dull pieces,
Yeah.
right?
Yeah.
Because you don't want that injuring, you know, sailors or submariners, right?
Yeah.
So kind of, I'm sure the same principle is, you know, in Humvees or whatever. You just don't want that causing injuries, right?
Exactly.
Yeah.
Or in the aerospace applications, if it's mounted on a helicopter, if a piece comes flying off, it has a potential to hit your rotor. And now, because of this one little component, your multi-million-dollar helicopter is now exploded. There's loss of life that comes along with that. So they take it very seriously.
Oh, I'm sure.
Yeah.
You have to, right?
But yeah, so like for this, you know, Commander brought us that cardboard design. This is like a pretty old thing for us. So in the past, what we might have done is, you know, taken the measurements, maybe even sketch this out by hand and cut it that way. Like long time ago, that's kind of how it would be done before computer aided design. And then if we want to pull up just any of the other photos, I can kind of show you how we do stuff now. Whereas you'd bring me that piece of cardboard and we would turn it into a 3D CAD model.
Gotcha.
Yeah.
You got some other photos for us, Cass?
There you
So
go.
Okay.
here's another product actually for Commander as well. So this is a jet ski cart, so that when you are toting your ski from your little booth where you're at and you're setting up and you're doing prep and then you're putting it in the water for a race, that's a full cart that has a handle and an axle for wheels and stuff. So up on the top there, you can see what it looks like in the digital space. So those are all, you know, individual components that we modeled to make sure that they fit exactly how you want to, you know, bolt holes are lining up, all that kind of stuff. And then taking that and, you know, putting it into the machine software so the machines know what to do with it, how to bend it, how to cut it, all that stuff. And then ending up with a finished complete part on the bottom there with everything from, you know, cut, bend, there's sanding done on that, there's welding and some assembly as well there too. So
Nice.
yeah,
I like in the drawing how it has the background shadows, so you can see up underneath it as well at the same time.
there is so much cool stuff you can do with
That's cool.
visualizations in CAD. Like there are guys whose whole career is making that bottom picture look like or the top picture look like the bottom picture, and you would like not even know. So we're a little bit more dumbed down with it, but it does help being able to see things. And that's also why we do like different colors. So like there's some green parts in there, there's some light blue parts, there's some gray parts, just to kind of help show you like
Differentiate where
yeah,
the-
so when you're looking at it, it's just not one big blob of gray. That doesn't really make any sense. Also helps the operators or the assembly person who's spinning the CAD model around to look to see how this thing is put together. They can see, okay, that's that part, that's this part, they're different colors, boom, they get put together. So
That's cool. Hey, Highlander chimed in up there, says, Ty, always a great guest. I always get to learn so much. Yeah.
there we go. I'll teach you about metal.
And he says, anything with a mil spec costs a lot of money, but it's good usually for a good reason.
Yeah, all of it is it. A lot of people like to see military spec stuff and look at the price and go, oh my goodness, because I can make that for this price. It's not about the how much like the material or the labor cost. There's a ton of time and engineering and quality control. Like that's where all the cost gets built up. So it might be a cheap part, but as soon as you want to inspect it and get mil spec coatings and do all the destruction testing and all that kind of stuff, that's where it all kind of starts costing a lot real quick.
Yeah, makes sense.
But yeah, and then we could tab over to the next photo there. So here's another cart that we did. This is more of a stand-up workbench. So same deal, but getting it all modeled up. And then you can even see that we can implement models for things that we don't even make there. So the brown boards on the side, those are 2x4s that are cut to size, and they put like a special, like essentially like a bed liner or like a carpeted type material on there so it doesn't scratch up your ski. And then we also use materials and products like the wheels there that we buy from sources that give you the CAD model too. So like that wheel, I can go on my supplier's website, download their CAD model for it, and then I can put that into my assembly so I know that it fits and there's not going to be any issues with it. And then also it gives me a better and more complete idea of like what the part's going to be in the end.
Yeah, when you're making a part, is there a big difference when you add, the casters to that? I mean, making it mobile, is that a different to you in the way you approach things? I mean, because you're talking about a piece of equipment that somebody puts something heavy on, could fall over, could roll over them, and could have some issues.
So our philosophy has always kind of been over engineer something. So somebody's going to put a very expensive ski on that. And if it falls over or, if it breaks and digs into the ground, they're not going to be happy. We definitely will err on the side of making something too beefy and too strong in order just to avoid that completely. So for something like this isn't going to go through any destructive testing. So I can't with 100% certainty tell somebody that, you could put 3,000 pounds on this thing and it'll still stay up. But I know that you can for sure at least put a jet ski on that and probably way more than that and kind of still be good. But the mobility aspect definitely does add kind of a layer of difficulty, just because you have to look at all the center of the weight is in the center of this thing, but it's supported out here on wheels by the side. So is it going to collapse down? All that kind of stuff. But the way we go about engineering it and kind of being strategic with a lot of our stuff and how we're bolting things together, where bends are, all that kind of stuff, that all goes into it.
Oh my gosh, you guys. The QT man. Can you engineer a stronger gas door for John's van?
Probably.
What's the story
Here's
there?
a backstory. I was going to get gas one morning, right?
Okay.
All right. Well, the gentleman put he put the money on the wrong pump, so I had to go back in. Well, when I went back in, I left my gas door open, okay? I come back out, and a gentleman was there asking me for money, okay? I'm like, no, I don't carry any cash. I don't have any money to give you. He got upset, and he took his bag, and he flung it at me, hit the gas door, it went and took off through the parking lot. So,
great, didn't need that.
So needless to say, it became an issue for a moment in time. I had to talk to the security guard at the store and everything else. Luckily, though, I found out that it pops back on.
Oh, okay.
So we were able to pop it back on with a little help. I thought for sure I was going to have to figure something out.
So serviceability and repairability. So that's also another thing that is a big part of design. So I can design something that is bulletproof, solid, has no issues, but if this part that maybe has a life on it that wears down, if I build that in a way where there's no way you can get to it to replace it, now once that component has reached the end of its life, now the whole assembly is garbage because you can't get to it. So that's another kind of thing that you got to look into, is like this, for example, somebody's pushing that along and smashes it into something and they tweak one of the arms. Well, it's all bolted together. So in theory, we could just give you just one new arm and you could keep the rest of your car. You don't have to buy a whole new thing. That goes into it as well, as making sure that what you're designing isn't a one and done. And as soon as something's wrong with it, it's the whole thing's scrapped.
During the start of your process, then you're assuming and looking at the longevity of it.
Yeah, for sure. And what would be that's something that we talk about all the time, especially with our off-road line, is okay, what's the weak point on this going to be? Let's try to theorize examples, and the guy who has no idea what he's doing, what is he going to do that breaks this thing, and how could we maybe prevent that? And people still never cease to amaze you with what they end up doing, but you at least have some opportunity to kind of correct something before it happens.
They're called beta testers.
But so this is how we would start a project. And then if we go to the next photo. Oh, that's just another idea. So let's skip ahead one more. But so this is how we do it now. So all of that blue area that you see there is a 3D scan of the car that you see in the bottom photo.
Oh.
So I come in with a 3D scanner and I generate a very, very precise image of the part. And then we create our design around that. So in the past, when we've been doing designs, you go through revisions. And any engineer knows what a revision is. It's essentially, I messed up the first time and now I got to do it a second time. So This has taken our revisional changes to products down from maybe like 3 or 4 takes to we're getting it done in the first try. So in the past, doing something like this, might have been a little bit too narrow or not wide enough, or maybe everything didn't line up. But this gives us a really good opportunity to look at the actual car and how our product would fit in that car without having to make it. And especially for our shop, we have a lot of setup time with our machinery. So it's like it runs very efficiently, but it just takes time to set it up. So to get one thing made, it would be very time intensive, where now we can just put this thing inside of the 3D model in the scan and, oh yeah, it looks like it fits, or oh no, there's a little corner right here that's going to hit the body panel and fix it.
That's pretty cool.
Yeah.
Is AI incorporated into any of this?
Not quite, but they're starting to play with it a little bit.
Yeah.
There's some AI implementation into SolidWorks now that they're kind of trying to figure things out. I've seen a lot of things where they're just trying to link information sources. So like McMaster is a very popular source for hardware. They have like plugins for SolidWorks where you can just press a button over there and it brings you up the whole catalog of 1/4-inch bolts, and I can pick one and then it automatically puts it in my model and it's there, and I can spin it around and do everything I want with it. So they're getting more in depth with like that kind of thing, but AI isn't quite there yet. I've seen a couple people working on projects where you could say, hey, make me a box with 2 holes on the side and it's this big, this big, this big, and then it generates a model, but it's all pretty limited right now. So
okay.
Yeah.
But it will be coming.
No, I'm
ability for sure.
I'm excited. It'll be interesting to see how it works. I think it'll take a lot of refinement to get it to the point where it's like really usable, but I mean, that could be said for any use case.
It'll take a lot of training, but you look at the videos that they create, you see them on TikTok or whatever, and there's obviously flaws with it, right? But the entertainment value is good enough that people are shoving stuff out there. So eventually, AI learns what we teach it, right? Mm-hmm. And hopefully in the manufacturing world, we've talked about this before, about predicting needs over time for different products. It's just going to be, I was going to say garbage in, garbage out, but good information in equals good information out. So I imagine with design, it's going to be the same thing. You describe it, it's going to learn what you mean by what you say. Yeah. And all that.
It would be really cool being able to feed it like our design, like not necessarily things we do for other customers, but things that have like our design ID and like our kind of signature to it, and then asking it to make something similar and then have it put all of those features that we would build in normally, kind of teach it that way.
I'd definitely be interested.
Yeah, definitely.
Yeah. Now, knowing the AI is here and whatnot, and we're selling robots now. We have robots on our website. Okay. So we're entering that world of robots. Have you thought to look down the road and say, hey, I could use a robot to do this particular job in my shop?
Yeah, definitely. The first big introduction of robots into the manufacturing environment was for welding. So welding arms with just a nozzle, a robot arm with a welding nozzle on the end of it, doing MIG welding for a lot of automotive components. So anything on your car was welded by a robot, 100% guarantee. That has kind of jumped into other things where they now have automated bending. So they can take a panel and pick it up with suction cups and flip it over and do all the complex bends that you need to right then and there. That's definitely very interesting. I'm starting to see more stuff with quality control too, where you have like a camera looking down on a flat surface and you could just set the part there, and with very little effort, it like traces the outline of the part and all of the holes and features and cutouts, and it can with accuracy say, yeah, that hole is that size. This is a good part. And that is actually some functionality that our 3D scanner has as well. I can cool. Scan a complete part, and then it'll kind of give me like a heat map of like red is out of tolerance, green is in tolerance, and it'll show me the whole part, which is, it's cool.
Yeah, for sure.
It's just definitely like use case. They're a little specific when it comes to, just using it all the time isn't necessarily practical.
Right.
Yeah.
but
I mean,
it'll get there.
and that's where AI, more specific models rather than kind of the world
Yeah.
is really where it can,
Yeah, for sure.
zero in for sure. Yeah.
I got some more comments there. You want to read those, Mark?
Yeah, Mr. Highlander, we do liquid and powder coating for a lot of industries, but we have 2 3D printers and the engineers are using them all the time. I get to learn and get paid for it.
That's cool. Nice.
That's always the best when you get a new toy and you have to, spend company time figuring it out. It's like, yeah, I get to play.
Yeah, there you go. And then he also says, I tried finding the robots on the website. I wound up getting a phone call from Chris on Gruber
Gruber
Motors. Yeah,
Wow. Are they not on the website anymore? I
they're
thought we
there.
put them up there. Yeah.
they're on comm and on power. I think.
I thought so.
Must be one of those, if you click on it, you flag something in the system, so you get a special phone call.
Flag the CIA.
You want a robot?
Yeah.
Hey, what do you want it for?
Oh, robots are coming, right? I mean,
Yeah, no.
they're going to be a part of our society, like it or not.
I think the robot dogs are cool. People, yeah. We'll see.
Hey, if I don't have to do laundry anymore, right?
Hey, sign me up.
It'll get rusty, dude. Didn't you watch, Gilligan's Island when they had the robot
Oh,
doing the
that's right.
laundry?
That little. This guy, you remember Gilligan's Island at all? Do you know the show?
That was definitely something my dad watched.
Yeah, we're dating ourselves there.
Yeah, I know of it, but I didn't watch it, unfortunately.
Oh yeah, you're not living till you've seen it. That's what I'm saying.
I'll add it to the list.
So what? I'm just gonna ask you. You enjoy doing what you do.
Very
you have
much,
a passion for it.
Yeah.
So what do you like? I mean, what's the best part of your job? What you would say that you enjoy doing the most of?
Yeah, that's tough because I have a lot of parts of my job that I enjoy for different reasons. I really enjoy like talking and working with like new customers and like you guys, for example, like you're constantly bringing me new stuff. So it's always, I'm not doing the same thing every day.
Yeah.
Adds like variety to it. There's also the aspect of like if I spend all week like just in the office doing office work, I start to get a little stir crazy. Like I need to go out and like have a pile of parts that I did. And I think for that reason, like welding is probably like my favorite hands-on activity. It's always a little bit different. Parts are always a little bit unique, so you're not doing the same thing over and over and over and over again. Sometimes you are, but that just kind of adds a little bit of variety, and it's a nice level of like skill and artistics like capability. So it's like you have to have some technical side, but also it's you're channeling that creative side of your brain as well too. So I like doing that stuff.
I get that. I get that a lot. It's operating out of both sides of your brain. You have to feed both beasts, right?
Yeah.
The creative and the analytical.
Exactly.
Computers kind of do that for me because I can be in the spreadsheet world or I can be in coding is really art, but like in the Photoshop side of things and really just visioning stuff.
Yeah, I see your memes.
Yeah. No, that's AI. I just tell it, what do you think of John today? And it spits out all kinds of fun
I
stuff.
get all sorts of fun stuff shot my way.
So clearly, at least one AI has been trained very well.
Yes. It understands. It knows the task. Understood the assignment.
Wow, yeah. So one last question I have for you today, because we are getting close on time, is safety is a huge thing here at Gruber, right? So you're working around a lot of machinery, you have a lot going on. Talk a little bit about the safety and how you take care of yourself so you're not getting injured or your employees aren't getting injured.
Yeah, the general rule of thumb is don't put your fingers where you wouldn't put something else that you wouldn't want injured.
Enough said.
Let me change that up a little bit. But that's generally, training. Training is like the biggest thing. Just taking the time at the beginning of an employee's career and just really, really hammering best practices and how to use machines and this is what could happen, and if this happens, do this, and just being like very, very hands-on with that kind of education. After that, like just PPE and stuff like that, things that are just obvious. Like if you sitting there grinding parts all day, put a dust mask on. Like you don't want to breathe all that stuff in.
Right.
Are you handling sharp parts? wear some gloves, like all that kind of stuff. The machines themselves have a lot of safety features built in them now. So like our punch, it has a laser light curtain. So I cannot physically walk up to the punch while it is operating. It'll stop itself because I broke the laser light barrier.
Wow.
Nice.
Same thing with our press brake, our new press brake that we got. It has a laser guard. So it's so tuned in that it knows if the part is there or not. So if you don't have the part in position, it'll say, well, there's no material there. Are you sure you're trying to bend right now? And then if your hands are in the way and all that stuff, it'll make you like press the button again to confirm, no, I want to do this. And that is the opportunity for the operator to be like, oh yeah, I should, fix myself because they were trained.
Check yourself.
Exactly.
Yep.
Yeah. Wow.
But yeah.
Well, I'm going to bring you a design I want you to take a look at. Cass needs some training wheels built for her motorcycle. Right, Cass?
We can get something sorted out. Make you some little brackets.
You can smack him. Smack him if you want.
I'm great on my corners now.
Are you?
There we go.
Yeah,
you're good to go.
I got, they call it chicken scratches,
Yep.
and mine are getting like wider for the wheel, which means I'm using more of the wheel than what I used to use.
Oh,
which
that's
is
a good sign, right?
Yeah.
because that means my leans are getting better. So
Yep.
instead of trying to force the bike to turn, I'm using the whole bike to do my turns.
Oh, that's cool.
Well,
Okay,
maybe-
good job.
I've seen her drive home. She needs training wheels.
Maybe we'll make her like a crash bar, wheelie
I
bar,
knew
or something like that.
That was way
They
too
have-
much, of a set not to spike for Aaron.
When somebody throws food at her when she's driving home, she doesn't dodge it very well either.
That's because I'm trying to eat it. I'm hungry.
Free food.
Yeah.
You
Last
can actually-
comment from Highlander. Other than my submarine career, I spent about 30 years in the metal stamping industry. That's why I really enjoy having your guest. I get to stay current.
Yeah.
Oh,
cool.
really cool.
A lot has changed, but a lot is the same,
Metal's
Yeah, that's
metal.
true, right?
Yeah.
I mean, the basic concept's
Yeah,
still
yeah.
there, even though the technology behind it has changed.
Right.
If anything, advancements in tech sometimes help remove things, and not necessarily help, but old expertise and old skill and old ways of doing things get lost, and then people don't know how to do that anymore. So it's kind of nice being able to learn how it was done and then how we're doing it now. So it's like, if you can't do it the smart, intelligent, technological way, let's go back to our roots and make this thing happen.
There you go.
Hey, Aaron, Highlander saying, be careful. I'll come to Phoenix pretty soon. He's calling you out, Aaron.
Yeah. All right. Well, we've hit our time mark. We
go.
appreciate you being here. Make sure to like, subscribe, and share this podcast. Time zones flip now. So
That's right.
we're still here at 3 o'clock Arizona time, but for those of you on the East Coast, that's 5 p.m. every Thursday.
Highlander sitting there saying, pretty soon, being relative, I run on Elon time.
Yeah, well,
Hey,
pretty soon we should just have a clock that just has one time and everybody's on it. And
Sign me up.
right?
Yeah.
That'd be, yeah.
Yeah, it's not even practical to have different time zones or anything like that anymore. It's just, it is what it is.
Yeah.
It's just a number. But, old habits die hard.
They do.
So as I was saying, like, subscribe, share this podcast. We'll be here next week, next Thursday at 3 p.m. For now, I'm Mark Beach.
I'm John Dotson, and thank you, Ty, for joining
Yes,
us
thanks,
today.
Ty.
Thanks for having me.